standard normal random variables. Z is a standard normal random variable. This is the symbol that we usually use to denote standard normal random variables. We're talking about a standard normal random variable if it's normal, but the mean is 0 and standard deviation is 1. So the density curve is going to be centered here at 0, and it's going to have standard deviation 1. You can check that. You can see how I've dropped my 1 right below that, and negative 1 right below the inflection points there. Okay. Nice property of these curves is that for these distributions is that the z-scores are exactly the numbers you see here down on the real line. For example, if I took 1 and subtracted the mean, I get 1, and then divide by the standard deviation, I get 1. If I take 2 and subtract the mean and divide by the standard deviation, I get 2. Okay, so the utility of this is, well, it's certainly used for proving theorems, but it used to be that we also used them for computing normal probabilities with tables like the ones in the back of your books. We don't do that anymore. We typically use technology, use some kind of software program like your calculator, like we've already seen, but we'll see how these things can be useful today. Let's take a look at an example. IQs are distributed. This is a fact. They're distributed approximately normal with mean 100 and standard deviation 16. So if you say, "Hey Ma, I got 100 on my IQ test," oh great, good job. Okay, you're average. Okay, so what if what if I wanted to know the 90th percentile for the IQ distribution? That's certainly of interest to us, isn't it? I mean, because if you know what the 90th percentile is, then you have something to shoot for. If you get if your IQ is higher than the 90th percentile, then hey, you're doing pretty well, right? Well, I don't know how to do this, but I do know how to get the 90th percentile for a standard normal. Okay, so let's take a look at that. In fact, let me move over here and we'll draw a picture. So my IQ distribution maybe is like over here. Okay, this is my actual IQ distribution. I could say this is the behavior of IQs. Okay, they would sort of pile up in a nice mound shape like that. And so the mean is 100, and this mark would be about 116, right? And then if I come 16 down, I'd be at 84. Now, I don't know what the 90th percentile would be. It's probably somewhere in around here, I guess. It's probably right up in here, maybe? Not sure. But what I can do, I do know I do know how to find the 90th percentile for the standard normal. 0, 1, 2, -1, -2. Okay. So let's see. How can you find the 90th percentile for a standard normal? A standard normal. Well, actually, I don't know how to do that either. I really don't know how to do anything. I can use the table in the back of the book. Okay, I could find 90% down in the body of the table, depending on how the table is written, and then find the mark on the outskirts in the margin of the table that corresponds to it. Or I can use my calculator and do INV norm. Okay, and I want it for because I'm actually going backwards. I want the inverse normal, INV norm of 90%. Okay, yeah, the calculator is finding the 90th percentile for a standard normal. Okay, and let me show you where that is in your calculator. You go to it's in that distribution menu again. Okay, INV norm. There it is. IMV norm. I want the 90th percentile. Okay. Press enter. Okay, it's at 1.28155 approximately. Now I'm going to mark that. It's right there, isn't it? Okay, so that means 90%, right, is to the left of that mark. So now what we really want to know is, though, is where do I make the mark over here that carves out 90%? Well, guess what? Can you find it? Can you find it? It's going to be sort of, well, let's see, this is like that, and this is like that, right? So it should be like right here, I think. You know what I mean? Yeah. That's what we want. So how do I move? How do I move from this mark here up to this mark there? Well, let's see. How do you, first of all, how do you move from here to there? If I have a mark here, let's put it here. If this is some number x, then the number that corresponds to this x value down here is just going to be right there, right? What is that? That's the z-score, isn't it? It's just, if I take x minus, these government pens, look at that, minus the mean, which is 100, divide by standard deviation, right? This is going to be x minus 100 over 16, right? That's how I'll get to that point. Now, but if I have a point down here and I want to go in reverse, well, what do you do? If you want to move this away, then the new point up here, and call this, we'll call this a, I don't know, we'll call this the 90th percentile for IQs. The 90th percentile for IQs, isn't that just going to be, let's see, if I go in reverse, I need to take this number here, 1.28155, but multiply by the standard deviation and then shift up by the mean, right? You see that? So if I'm going to standardize, I do this procedure, right? I shift down by mu and then rescale by the standard deviation. Squish it in, compress it, or blow it out by the standard deviation, right? If I want to go in reverse, then I blow it out around 0, right? Because that's what happens if you multiply by a number. You're going to expand or contract around 0, and then add and shift up by the mean. Okay, so the standard, so the 90th percentile for IQs is going to be, what, it's 1.28155 approximately, times standard deviation of sigma, which is 16, sorry, plus 100. And that works out to be about 120. Okay, so if you've got an IQ of 121 or so, you're doing pretty well. Now, it turns out, though, that actually you don't need to know all that to solve this problem, but it's extremely useful to think that way, because it turns out if you know something about standard normals, then if you prove something about standard normals, you can essentially prove the same statement for all normal random variables. Now, turns out You could also do it like this with your calculator. You could do INV norm of 0.90 and then put in the mean and the standard deviation, and you get 120.504. Okay, so if you leave these last two fields blank when you do that command in your calculator, it defaults to a standard normal. If you put in the mean and the standard deviation there, then it'll find the whatever percentile for that kind of normal distribution.